Task 8. We need to determine whether your dataset or your responses have any influential points and whether they should be removed from the dataset, which will help us find an optimized regression model or prediction equation. We also need to make a new scatter plot with our data points and our optimized regression equation. We should also use the regression equation to make a prediction. We can randomly choose a number from our domain, our explanatory variable values, in order to plug in for our explanatory, calculate the response value that goes with it, and interpret the results by saying what this means for MA students in your population of interest. And then we're going to go back to the results section and look that up. So I'm actually going to move my screen over. So my data set, my entire data set, and you only need to do this for your entire data set, is in L1 and L2 right now. To check for X value outliers, we're going to use the IQR rule. So our X values right now are all in L1. So I'm going to hit stat calc 1 variable stats on L1, which is my X values. So my X bar is 3.297, which I don't need for the IQR rule. I need that Q1 is 1.75 and Q3 is 3.85. So this is for my X values. So we can use the IQR rule. Remember, low outliers are lower than Q1 minus 1.5 times your IQR. The IQR is Q3 minus Q1. Your high outliers are going to be numbers that are greater than quartile 3 plus 1.5 times your IQR. So we can calculate those, but I'm going to speed up my process a little bit here since I just ran these. I'm going to run a program to run the IQR rule. So anything above 7 is going to be a high outlier. You can't be below negative 1.4 miles away from school, so we're not going to have any low outliers. And then we just have to go through and look through the list and find any numbers that are greater than 7 in the X values. Now, you might want to go and store the rest of your numbers somewhere else. So let me recopy this into L1, or L1 into L4, and L2, copy L2 into L5. Because the whole point here is that I need to remove some data points. Again, any X values that are above 7, I need to delete the X and the Y that go with them. And make a record of all of the points that you are going to remove. Again, once you've removed all of them, you can go back to stat calc 4, or whatever your best regression equation was. Mine was linear. Linear ended up being the best for me. I run that on L1 and L2, and I find a different equation than I had before. Now, again, in order to speed this up, I've already done a lot of this. By my IQR rule, we need to look at residual outliers. So we need to find the residual list. Again, I'll show you how to do that in a moment. But my X outliers, my high cutoff number was 7, my low was negative 1.4. I removed these 5 points from my data set and got a new equation with a new R squared value and a new R value. I also made a note of what my full data set was. This actually ended up being my best regression equation because my R squared value was the highest. Again, the residual outliers, we need to find the residual list for everything in there first. So I'm going to actually copy my full list back so that now I've got my full list again. So to find my residuals, I need to run my best regression equation one more time to get that residual list into memory. Now stat edit, I'll use L3 as my residual list. Second stat. Resid. There are all my residuals. And actually, because of the program that I wrote, my residual values I need to put somewhere else for a second. One moment. Okay. And then stat, or sorry, no. Now you would go stat calc 1 on your proper residual list to find your quartiles, and then use those to find the IQR cutoff numbers for high and low residual values. Again, this isn't just Y values, this is actually residual values, because high and low Y values could be possible depending on how far away they are from our expectations. But again, I wrote my IQR rule program to help myself speed this up a little bit. So my upper and lower limits are now set. Stat edit. I needed to do this for my formula. So my two cutoff numbers were 24.156 as a high number and negative 29.020 as a low number. I'm looking through those values here for high and low values because these are the residuals. And when I have a high or low residual, I actually need to remove the points that go with them. And so in order to do so, we need to delete 1, 2, and 3. So that now the next high residual, is that too high? Nope, it's not above 24. It can be left in and it's in the right place. 2.1 comma 60. Delete, delete, delete. Again, once you've done all of this, now you can run a new regression and find a new set of values and see if you have a higher or lower R squared value. My R squared is ridiculously low at this point. Actually, it turned out to be very, very low in the final version. I removed these 6 points to get the residual outliers removed. And the last version you have to do is removing both the residual outliers and the X value outliers. Once you have all the 4 of those models, look at your R squared values. If any two are the same, then look at the R values. Highest R squared value is going to be the best predictor. And again, 0.0004, not very good. 0.03, 3% accurate, not very good. 0.0007, or 0.7% accurate. 6.7% accurate is not very accurate, but that's what we've got for right now, and that means that our full set is ultimately going to be our best bet. Now, another thing that we can do is we can go back to our full data set. I know I deleted a few things here, so this is why I've stored them to put them back. And we can randomly select a number from the domain. The domain is, again, my X values. So my lowest number is 0.5, my highest number is 23. So we want to pick a random number, and you can use the math button. Go all the way right to PRB, and we'll do a random number, and we're just looking for anything between 0.5 and 23, and 0.73 seems to be my random number. Now, if you have higher random numbers, you usually just get decimals here. So you might want to choose random integers, math, all the way over to the probability, random integers from 0.5, which is not an integer, so from 0 to 23. Okay, what if somebody lived 8 miles away from school? I'm going to use that number. So now that I've got my random number selected, that means that if a person lived 8 miles away from school, I would get 1.054 times 8 plus 7.807 absences or tardies. 1.054 times 8 plus 7.807 means that they would probably be absent or tardy about 16 times. And now we get to go add that to the write-up. Oh, I almost forgot to get the new residual plot. Remember the new residual plot? Well, I ended up using the full data set. So let's run my regression again for the full data set, get the real residual plot, stat edit. Actually, we don't need to do that because we can take plot 1 and just leave it as L1 versus the residual values. Hit graph. Remember to hit zoom 9. And that should be what my graph looks like, my residual plot. And you can always just take a photo and then add that to your document later. Speaking of the document, let's go back. My optimized regression equation was still my original linear regression that we came up with from the full data set, but we needed to say that anyway. We've also made the new scatter plot with the data points for our optimized regression equation. And our regression equation I've used to make a prediction. So these are going to be in the results. So when looking for influential points, our linear, exponential, or quadratic model, again, we found. So let's start adding this to my results section. And there I've put in the quadratic regression equation. Here I put in the residual for the all responses, which was actually the one that I already took for later on. But again, this is one of the things I like about any of this. It'll be boring formulaic writing, which is a little bit easier. So when looking for influential points in our linear model, we found, let's see, let me count up again, 5 X outliers, which are also called high leverage points, and 6 high residual outliers, which are known as influential points. So I suppose we were looking for outliers in our linear model. However, removing these points from the data set made the prediction model less effective. This means that our optimized regression model is, and I'm just following the same sentence stems that I gave you guys. Y hat equals, I'll show you how to get a y hat later if you need, 1.054x plus 7.802. The r squared value of our equation was 0.067, which is well below 5, so which indicates a weak relationship between our variables. If you want to add the R value, was 0.258, which indicates a slight positive correlation. You can say that because, again, 0.25, not very much, but it is at least a positive number when you look at the R value. The scatter plot and optimized regression equation for our data set is given below. Now, I didn't have to change my picture, that's okay. And also, we've already said what our overall best set of values was. Now, why did we make a prediction? We actually made a prediction for the next part. The next part is going to be our set of conclusions and discussion. So our discussion kind of involves this idea of when I plugged in 8, I'm just making a note for myself to talk about this later in the discussion. When I plugged in 8 as the number of miles a student lives from MA, the result was a prediction of 16.239 instances of absence or tardy. And we can use the rest of that in the next part.